Okay, 4 or 5 is about concentrations of solutions. So we're going to very quickly run through molarity and then talk about solutions with known concentrations and dilutions, and then finish with the next section that's going to tie in with titrations, which is something new. So a little bit of review here. So what is concentration? Okay, let's remember that concentration is the amount of solute dissolved in a quantity of solvent, and there are all those different ways we looked at in chapter 13 about how to determine the concentration of a solution. We're going to look mostly at molarity here. So remember that molarity is at uppercase M, and it is so many moles of solute divided by your liters of solution. That's the most common one, and that's what we're going to deal with in this chapter. Okay. Now, expressing the concentration of an electrolyte, we talked about what those are. Remember, electrolytes are where they break totally apart in my solution. So when we talk about an electrolyte, we're looking at an ionic compound, okay, and, well, in particular here, an ionic compound dissolves, all right, as do any strong electrolyte. So the concentration of ions depends on the formula. Just kind of dealing with that molality stuff that we looked at, with if I have more moles of something when it breaks apart, I have higher molal, which changed my vapor pressure and such. Same kind of thing here. All right, before you have the NaCl, I'm going to dissolve it in water. Remember that breaks apart into Na plus and Cl minus. I go from having 1 mole total to having 1 mole of each. There's a total of 2. So let's keep that in mind. Okay. I'm going to look at an example. What's the molar concentrations of each of the ions present in a 0.025 molar aqueous solution of calcium nitrate? Calcium nitrate is CaNO3 because the Ca is a 2 plus. Of the overall concentration is 0.025. I don't know what the concentration of each ion is. Well, I have 1 calcium ion there, so I'm going to have 0.025 molar concentration of Ca2 plus. Because again, remember that's going to be swimming around in the solution since it's going to break apart, since it is a strong electrolyte. Well, for each Ca that breaks apart, I have 2 nitrates that's going to kind of break off. So I'm going to have 0.025 times 2, which is going to be 0.05 molal for the NO3 ion. And give the concentration of each type of ion in a 0.5 molar solution of CONO32. Same thing here. Okay, if I have 0.5 molar total, I'm going to have 0.5 molar of the cobalt ion, and then I'm going to have twice as much of the nitrate to be 1 molar of the nitrate ion. As for each one, it breaks apart. Your liters are the same, which is why then the molality changes as your moles change. Solutions of known concentration. How to make a standard solution. Okay, solutions whose concentration are accurately known, we call those standards. We call those standard solutions because we know their molarity very definitely, so we can have those as a standard for everything else we may not know. Okay, you add grams of a substance and then dissolve in water in a volumetric flask, and we already talked about this in chapter 13, and then you fill flask to desired volume. That's how you would make that particular substance. So let's look at an example here. To analyze the alcohol content of a certain wine, a chemist needs 1 liter of a 0.2 molar potassium dichromate solution. How much solid potassium dichromate has to be weighed out to make this solution? Let's remember back to molarity. Molarity is moles per liter. I have a 0.2 molar solution that I need to make. I need to know how much I'm going to have to add, so I need to know my moles here. And I have 1 liter, which means I'm going to have, when I multiply, 0.2 moles. So I have 0.2 moles of potassium dichromate. Well, you really want to know how many grams. You don't weigh out moles on a balance. You need to know grams. So I take my 0.2 moles and I multiply by the molar mass of potassium dichromate, which is 294.2 grams in 1 mole. So I'm going to get the answer here of 58.8 grams. So you would add 58.8 grams of that potassium dichromate to make that molarity of a solution. And that's something that chemists do all the time when they're making solutions. Okay? So most of the time you'll make a solution from scratch or from amount of grams. You can also make it from an amount of liters or another known solution molarity. Okay, and this is the dilution. You purchase a stock solution and then dilute it to the desired molarity. A lot of times these are solutions or solids that are not very stable when they are by themselves, meaning they tend to react with moisture in the air, or they just don't last very long, they decay. So you make them into a stock solution, and then you don't have to worry about how long they can actually last as a solid. So what happens to the moles of a solute in a dilution? When you're diluting, your moles stay the same. This is by definition a dilution. Means that you are making it less concentrated, so all you're doing is adding more water to it, or your solvent. You're just making it weaker. So since your moles stay the same, I don't kind of have to deal with moles when you deal with a dilution, or how much of this I have to dilute, how much of this I need to make a certain molarity of a lower amount. So we can just use a very easy equation where you have M1V1 equals M2V2. Because your moles stay the same, remember that molarity is moles per liter. So molarity times liter, or my volume is my moles, while the moles before equal the moles after. So we can just do it like this: M times V equals M times V. It's very easy. It doesn't matter which one's which, because as long as you have the same correct things on the right side. So let's try one here. How many milliliters of 3 molar H2SO4 is needed to make 150 milliliters of 0.1 H2SO4? You always have to dilute to a smaller concentration. So if I have 3 molar times some volume equal to 450 milliliters, now molarity by definition is liters, so I gotta have 0.450 liters times 0.1. So I multiply, and then I'm gonna divide by 3 to get the B by itself, and my volume is gonna be 0.015 liters. It asks for milliliters, so that is 15 milliliters that I would add. Go ahead and try the next two. So for the second one here, you should get 5 milliliters that you're going to have to add to make it more dilute to 0.1. And then the bottom one here, you should get an ending concentration of 0.4 if I dilute 10 molar to 250 milliliters.